然后 the first one will be dealing about WebKitGTK, and the second will be about a keyboard library, EEK board, and the third one for Li Shiyuan will be talk about the Debian policy. And okay, then we welcome to our first speaker, Xan López. Xan López is working in Igalia, and he's also very experienced in GTK and in GNOME development. And today his topic is about WebKit and GTK, a joint implementation of both, right? Okay, let's welcome.
Wow. What's this?
Oh, this is my book.
Yeah. Oh, does this in Magnus?
Sorry, I'm not familiar with my book. Oh, sorry. Hello, Xan.
Yeah.
This one is familiar with Mac.
Not Mac, but
Well, it's just.
how to show the slideshow.
Yeah.
Oh, so I got that, but
I think I just exported the PDF.
它两侧的画面都一样，可是两侧都投成那个 slideshow，两侧都投成那个这样的简报。OK， good。
Okay, so I'm Xan López, as he said. I've been working on GNOME for about 6 years now, or so. I'm a foundation member. I also work on the WebKit project, where I'm a reviewer. I have been involved since 2007, and I maintain the GTK port of WebKit. And I work for Igalia, which is a Spanish company, free software company. So first of all, I want to talk about what this talk is not about. I'm not going to talk about how web applications and the difference between web applications and desktop applications and how they are changing the way people see applications. So I'm not going to talk about any of this. I'm also not going to talk about the cloud or how to put data in the internet and how to make the desktop applications interact with that. I'm just going to focus on one thing, which is that the web as an application development platform is kind of winning against the desktop world. And what will be the reasons for this? One of them is that it's everywhere. If you write a web application, you can kind of assume that more or less everyone has a web browser and can use the application you write. So by writing web apps instead of desktop apps and just targeting one desktop like Windows or Mac or some Linux desktop, you can really reach lots of more people. Yesterday I was looking for some kind of data, and I saw this that says that there's close to 2 billion users of the internet with web access and internet access. I don't know if this is more or less accurate, but I don't know, since it was in the internet, I will just assume it's true. Also, another thing that web development has over desktop applications is that it's really easy to get started. You basically just need a text editor and a web browser, and you can just write something and make it appear on the web. And if this continues for a long time and the web really keeps catching up with the desktop and technologies and people keep writing just web applications, it might just happen very soon that the web will become the dominant platform in the future for application development instead of GNOME or anything else. And some of you in the audience might say, well, this is not really very different than now. GNOME is not really in any way the dominant the platform for application development, and you're right. So what we can do, we can try to do is something I did this time, instead of trying to keep fighting with Windows or Mac in pushing our desktop application development frameworks. Maybe you can try to catch up with the web and integrate the web into our way of developing applications. So what will be a reasonable plan to do this? I think has two steps. The first step we started a few years ago involves WebKit, which if you were in the talk that Holger did just now, he gave a reasonable introduction to what WebKit is, but if you were not there, just very briefly, it's a portable web engine that powers some of the most popular browsers nowadays, like Chromium and Safari. It's about 2 million lines of C++ code, and it's architecture in a way that allows it to be native in very different platforms. So what we wanted to do was to integrate WebKit into the GNOME platform. And for this we started WebKitGTK, which is a part of WebKit that it's written using the underlying libraries for the GNOME platform. So for instance, for graphics development we use Cairo, which is our graphics library. For network we use Soup. For accessibility we use ATK. For font rendering we use Pango, and so on. The list continues. So we use the platform. We expose native GTK APIs for all the functionality in WebKitGTK. So if you are writing GTK applications and you would want to use WebKit, we give you a series of widgets and APIs that you can use that are GObject based and are completely native for the platform. The main one is one called WebKit WebView, which is the basic viewer for the web content that you can embed in your application to show any kind of web-related content. Since we started this, the WebKitGTK project has really seen big adoption. It's used in many browsers, including Epiphany, which is the official GNOME browser, but it's also used in instant messaging clients like Empathy to do theming. So what they do is they get in macOS 10, I'm client in macOS 10 has theme files that are actually just HTML and CSS. So what they did is implement the support for those files, so you can show different kinds of layouts for your conversations, and they are compatible with the macOS 10 application. It's using email clients to render HTML emails. It's used to display the help in the GNOME desktop, and so on. The problem with this is we were missing a really important feature in the WebKitGTK platform, which was there was no easy way to access and modify the web content. We were not really giving the appropriate APIs to do so. So I will just show you a few examples of the kind of things we had to do in the past. Let's see. Yeah, so as you can see here, in March of 2009, I wanted to implement a translucent link message status bar. What this is basically just like in Chrome browser, if you have used it, when you hover over a link, actually I think I can show you an example. When you hover over a link, it will show this gray rectangle on the bottom, and when you hover away, it goes away. So I wanted to do something similar in Epiphany. So basically what you have to do, the solution I devised was to just inject some HTML code in the page that will show this rectangle. But as I said, there was really no convenient API to do so. So basically, I had to write this huge string of JavaScript code. And as you can see here, I put some fix me saying, get rid of this stuff as soon as possible. So it's basically this huge chunk that you write there, and then you just use a function which is called execute script. So you get the view, and you tell it, just get this string of JavaScript and execute it in your context. And well, it sort of works, but it has a very big problem that it's very difficult to debug. So if you made some mistake in this string, it's basically pretty complex to figure out what's going wrong. It's also very painful to write this and blah blah. So people were not really using this a lot. There was another way of doing this, which was using the JavaScript core API. So if you want to access the web content, another thing you can do is use the JavaScript core APIs, which are a C-based API for the JavaScript library that WebKit has. So for example, if you want to get the links in a web page, you just have to create a string using these APIs of JavaScript core, make a JavaScript value out of it, call it as a function, blah, blah, do sorts of things. I mean, just to do a very simple thing, it takes a lot of time, and you have to write very verbose code, which is not convenient to write. And this, in this example, some GNOME developer moved this implementation from using JavaScript core to using the new DOM APIs. And as you can see, he was able to do exactly the same thing using about 100 lines less of code. So, you know, that's a pretty impressive way of explaining the difference between the two kinds of APIs. So basically, until very recently, we were in this stage where we just had these two ways of accessing and changing the web content in a web view until, in both these examples, we are using the DOM APIs, which is basically the way you have to use and modify the content in a web page. In both of those, we are using JavaScript in one way or another. In one, we were writing JavaScript directly in a string. In the other, we were using some APIs. And actually, using JavaScript is the way most people know how to access the content in a web page or how to make them dynamic. So, I mean, this is one example that might be familiar to most of you. Just get the element in one page which has an ID of foo and just set a color of red for it. But actually, if you read the spec, the DOM says that it's designed to be used with any programming language. In order to provide a precise language-independent specification to the DOM interfaces, we have chosen to define the specification in OMG IDL, which this is not what it seems to be. It just means Object Management Group Interface Definition Language, which is a sort of a standard way of defining what an API looks like. So this is one real example of WebKit, is the ideal definition of document. And I mean, the details are not very important, but it tells you it's an interface, its superclass is node, there's attributes, it has functions which have return values, parameters, it can have annotations that WebKit can use for different purposes. So since you have this, and WebKit is structured in a way that allows you to write code that, knowing the names and the types of these functions, you can actually use the underlying implementation of the DOM in WebKit. You can fairly easily write an implementation that uses GObject and C to access the DOM in the WebKit. So now I'm going to show you one example. I just wanted to ask how many of you are familiar with GObject and GTK programming? How many of you are familiar with GObject and GTK programming? Okay, not many of you. Okay, so maybe I can do it, I don't know, from scratch or something. So I will try to go slowly and explain everything I'm doing. Okay. To begin with, we have to include the WebKit headers. And then you are just going to write a simple GTK program. So we can do. First of all, we're going to create a window where we will show just everything we have. We have to initialize GTK. It's just there's some magical things we don't really care too much about. And in the end, we just run the main loop. The main loop is the thing that keeps waiting for the user input and will make the program react to what we do. So we create a new window. It's a top-level window. And we show it. Right? So we can go here. And then we just tell it to to compile using the GTK, the WebKitGTK libraries. So if you do this, oops. Oh, it's hello, sorry. So if you do this, you just get an empty window. One thing that you usually do is you connect to this delete event, and when it's received, you exit the program. The delete event is an event that GTK generates when you click here in this X in the window. So it will generate an event called delete, and when you press, we tell the program to just quit GTK. So it finishes. So now that we have this basic stuff, we can create a web view. So WebKit web view new. We had to add it to the window. So we do it like this, and that's it. And now we should show some content probably in the web view. So you can just create this very basic content. Let's see, like this. And we just tell the web view to load the content we just defined there. So WebKit web view load the string. We have to cast this to web view because we define it as a widget. I didn't name it. So content. And then there's some parameters here that we don't care about. So if this compiles, okay, that didn't make any sense. Still nothing because we told it to load some empty content, right? So now I'm going to show you how to use actually the DOM bindings to set some content in this page. So first we can create here an empty paragraph like this. It doesn't have anything. And now we're going to set some content on it. So first, there's a signal that the web view has. Which tells us when it has finished parsing the content we have set on it, so we can do whatever we want with it. So we want to be notified when that happens. So we connect to the signal. We receive the view where this happened, and the user data which we pass null, so we don't care at all about what's coming on here. And just to show you that this works, we can say hello here. So now it's telling us it has finished parsing the content. So now we want to set some content on this paragraph that we set. So first we need access to the DOM document, which is a top level object in a DOM structure. And you can access to it from the view. So you do it like this. Once you have the document, you have access to the DOM MPIs that we are all familiar with. I gave one example here. So in document, you can ask for an element by its ID. So we are going to do just the same thing. So we do, it's going to return an element. Document. And we set the ID as full. And once we have the element, we want to set some content on it. So we can just do it like this. It's an HTML element because it's a paragraph. So we have to cast it because we define it as a normal element. and we can do this. And this is for the error, but hopefully there's not going to be any error, so we don't need to do anything. Okay, that was... Okay, so we managed to set some content. As you can see, the point of this exercise is that we are using the same DOM APIs that are defined usually for JavaScript programmers that everyone is familiar with, but now we have defined them in a way that is familiar for any GObject programmer. So, you know, you have typical GObjects like the document, the element. You have the same APIs that everyone knows from the DOM. So, you know, it's pretty reasonable, easy for any GObject programmer to use this. Another thing this provides is actually access to all the events that happen in the DOM tree, but they are exposed as normal events. So if you remember this delete event, it has a name, then this dash, an event. And you can pass a callback, and when it happens, the callback is executed. So for instance, we provide something very similar in any element. Let's say a click event. When you click on the event, the callback that you define will be called. And it just works the same way that the normal GTK events. So you go here. Actually, this was wrong. Doesn't matter. So the element that received the event itself, and the user data that, again, we don't care about. Here we just told that we are not doing anything. We won't let the event go. In GTK, all the event callbacks return a Boolean value. If you return true, you are telling the program that you handled the event and you don't want it to continue further. If you return false, it means let the process continue handling the event in the upper layers of the system. So we don't want to block it in any particular way. And for instance, what we can try to do now is just to change the text that is in the label, in the paragraph when we click on it. So we can just use the same function we used before and do this. It works. More things that this supports. We can actually, the same thing that I did in my example, we can access the style information of any element and we can modify it. So let's try to do that. This is called WebKit DOM CSS style declaration. The names are a bit like strange in some cases, but that's just because we are taking the names directly from the IDL. So it's the standard names that are defined in the spec. We are just exposing them directly in GObject. Maybe we will want to provide different names so they are easier to use, but for now we are just sticking to what the standard says. So style, we get the style from the element. And we can set style properties that are normal CSS style properties. So the style, we can set the color, red. This is a parameter that is seldomly used, which is the importance of the CSS declaration. We should probably make a function that accepts this as a not mandatory parameter because you almost never use it. So let's see if this works. When you click, it changes, and it also changes the color. Thank you. And we can keep using, I mean, you can use any of the CSS things you know from normal web programming. So, like, I don't know. You can set the font really big. And so, I mean, what time is it? Okay, I think I have time. So this is just one example I did from scratch, so you can, hopefully you saw more or less how you do things. And you see that there's really no difference between the DOM APIs you use and the normal GTK APIs. It just all feels the same. You use the same semantics, the same names, the same stuff. But I actually have a few more complicated examples that I did before the talk. So one, during WebKit, I needed an application that, I don't know if you have seen the movie War Games, but in War Games there's a DEFCON, when they are in this military base in the US and there's this fake war going on, they have a DEFCON panel which changes from 5 to 4 to 3 to 2 to 1. And when you reach 1, it's like World War III and the world ends. So I wanted to show something like this as a joke in my talk, but there was no application that did this. So I figured I could write one using just web technologies very quickly using WebKitGTK. So I did an app that allows you to change the DEFCON level from any 5 to 4 or 3 to 1. So for instance, let's change to 3, from 3 to 2. Oh, the resolution is wrong. Let me check one thing. What? Oh, yeah. Okay. Yeah, okay, the resolution is not okay, but, well, more or less you can see how it works. I don't know if you can listen, but it actually has sound. Oops. Okay, so that's pretty much it, but it's actually very similar to the application we were just writing now. Just creates a window, sets it in full screen, creates a view, adds it to the container, loads a file with the data. So this is actually an HTML file I wrote, which is just, a bunch of divs with each one for one number. It has an audio tag, which is what I use to reproduce this sound. So, instead of using some complicated sound library, I just have this tag pointing to some WAV file. And in the program later, I just tell the thing to play. And here's the style information, which is in line, which is, some basic style for the DEFCON squares, one color for each one color when they are inactive, and then just the label that is in the top, the DEFCON thing. So that's pretty much it. And the program, it loads the data you pass. It connects the same way to the document load finish. And what it does here is set, first it gets a document, gets the square you pass as the parameter. Like if you pass 5, it does a query with div which has a class 5 using query selector, which is actually something quite new, which is in WebKit and Mozilla. You can do DOM queries using CSS syntax. So in this case, we are just saying, give me the div which has class 5, which is a parameter we pass to the program. It returns it, and it sets it to active. So if you remember, when the program starts, for half a second, it will be active on 5. So it waits half a second, and it increases the DEFCON, which increasing the DEFCON is just getting the div which is active, which we just set to active, which will be the 5 in this case. It sets it to inactive, gets the next one. In case we were in the first one, it actually loops and goes to the first element in the box. So you can actually go from 1 to 5, even if it doesn't make much sense. But, I was trying with 1, it crashed, and I figured, well, I shouldn't allow it to crash. Then it gets the audio tag, which I define with this audio thing, and it just tells it to play. And here there's some fix me, which you don't need to look at, but, well, it just waits for the duration of the web file and then just quits the program. So fairly simple. And I have another example. Let's see. I think I compiled it already. Okay, so this is a cloud with snow falling. That's it. And now we can see a bit how it's implemented. It's all using web stuff. So by now this should feel familiar to everyone. We just create the window, add the view, blah, 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 load the content. The content is actually, it's pretty much nothing. It's just a link to a CSS file, which is here, and then one SVG, which is, you know, this huge thing I just copied from the internet. I think it has an open license, so it's all legal and fine and great. But, you know, just don't tell anyone, just in case. And it's actually using one nice feature from HTML5, which is you can just embed SVG in an HTML document without doing anything in particular, like not using object tag or using plugins or anything. This only works in fairly recent WebKit builds, but it works in mine because I'm using a development build. So what this does is just shows the cloud in the middle of the page or in the corner of the page, and links to this, which sets some basic style information, like the background, the blue background for the page. And then let's see what the program does. When the document is done, finished, it says create snowflakes. So we go to see what create snowflakes does. Flakes. This is actually amazing. These are the Unicode points for the snowflakes. So in Unicode, there's characters for snowflakes. When I found this, my mind was blown away. Then we have an array for the sizes, because if you remember, some snowflakes are very small and some of them are bigger and some of them are really big, like this one. So you have an array with some frequency set, so it will show them with different sizes, sort of randomly. We get the document and then we create 25 snowflakes. And I mean, maybe we don't have to go through this, but basically what it does is creates a div where it sets a class snowflake and it positions it sort of randomly in the page, and then it sets also randomly, as you can see here, it's using the random function for the Boolean. It's returning true or false randomly. So if it's true, it will the snowflake will turn clockwise, and otherwise it will be counterclockwise. It says the style properties for animations that I will show you how they work now, and then just adds it to the page. I think we can, here you can see it's adding the snowflake to the page. So it's creating 25 random snowflakes moving randomly and adding them to the page. And the beauty of it is that all the animation is just done with CSS animations, which are available in CSS3. So basically, for each snowflake, you just tell it that for infinite duration and some functions to control how the animation exactly behaves, it will drop. Which, if you go back here, you can see it's what we set for each snowflake to drop and fade. Because when it reaches the bottom, I don't see if you can actually be able to see it. Okay, no. When it reaches the bottom, it actually fades away. So each flake will fade and drop, which are CSS3 animations we just defined here. As you can see, it's fairly easy drop. It just means move from this position to this position. When you are 0%, you start here. When you're at 100%, you have to finish here. And fade just means control your opacity, so you start like visible, and when you are 100%, you are invisible. And the other animations we set are counterclockwise spin and clockwise spin, which are just rotations from some degrees to the other, like from -50 to 50 or from 50 to -50. These are just different classes for the sizes, which we set randomly, and that's pretty much it. And the thing with this is that instead of, if you were using some GTK animation library, you'll probably have a fairly reduced amount of examples available in the web. Hopefully some really good examples in the GNOME documentation project. But, you know, since GNOME is not extremely widely used, there's probably not many people using it to do these kind of things. But for CSS animations in the web, just Google anything and you will get like thousands of examples. You can just take, modify, see if it does what you need. You just put it in your program. Then with the DOM APIs, you just set a few parameters to them and you can just get the animations that were defined in the web page. And it just looks exactly the same because it's using WebKit, the same that the web page you were rendering in your browser. So I think that's a fairly convenient way of doing animations or all the other things I have shown that you might need to do. So that's pretty much it for the demo, I think. This is a work in progress. We started doing this like, I don't know, last year, more or less, so we have been working on it for a few months. There's still a few things to do, but as you can see, it's fairly complete and you can already do quite so many things. If you want to use it now, it's already available in the stable releases we are doing of WebKitGTK, starting from the 1.3.0. The next stable release will be the 1.4.0, which will be released around March next year for GNOME 3.0. And if you want to join us or ask any questions to us about this or other WebKitGTK topics, you can join our IRC channels. Most of the development team is in both of these channels in Freenode. And the WebKit from the page for the main project is webkit.org, and then there's the specific web page for the GTK port, which is webkitgtk.org. You can visit any of those, and that's it. So if you have questions or...
Yeah, any questions?
So is it possible to code a GTK main program inside the HTML with JavaScript?
Okay, I don't quite understand what you mean with the first thing. What do you mean inside HTML?
Because now we try to interact with the web content inside our GTK programs, but now you can connect to the signal, the DOM signals and do some signal handling. But can we do it in an opposite direction? For example, we code a GTK program inside the HTML content with JavaScript. Is it possible?
Okay. So basically, it's not quite related to the GObject DOM bindings because you're going in the opposite direction. So what you need to do if you want the JavaScript in the web page to be able to access the GTK APIs is to share. You need to share the JavaScript context of the. It's fairly complex actually, but you need to be using a JavaScript binding library for the GObject implementation, which is called SID, which uses the JavaScript core engine. And you need that library and the JavaScript in the library and the JavaScript in the browser share the same context. And then you can just access from SID the JavaScript code or the other way around because they just share the context. But this has actually fairly serious security implications because if you allow the JavaScript in any page to access all the GTK stuff, they can just go and delete your hard drive or wherever. So it's probably not a very reasonable thing to do unless you are sure it's just for local content. So I don't know. There's people experimenting with this. It's called a SIDKit. You can just Google it, and it's a project to share the context so you can just access, as I explained, the theme. But, I don't think they have thought through completely the security implications. So if you're planning to do that, just see what you're doing and see if it's safe or not. I don't think that having the JavaScript in the page itself, using the APIs of the system, is mainly a good idea. What I think is much easier is to just write the JavaScript using the JavaScript bindings for our platform, and then use the GObject DOM bindings through JavaScript to set the web content. So that's much safer because you're going in the right direction. You're just always going from the program to the bottom. So I don't know. I think I will do that, but it's up to you.
还没有人有问题的。So, and I think this is this is really cool, amazing. I was really totally shocked, and yeah, myself is really shocked for how amazing it can be, and so it is already a mature library in production status.
So WebKitGTK, we have already made 2 stable releases. So it's, I don't know, it's fairly mature. I think it's used, as I said in the slides, in many projects. The GObject DOM bindings are still not in any stable release because they are still work in progress. So the API for this particular stuff I've shown today is not stable. We might change it a bit yet. That's the reason we are doing unstable releases still with it. But as I said, we hope in March of next year we will make a stable release. And from that point on, you can rely on it being completely API stable.
Will it be supporting HTML5?
Yeah, we support it already. And some of the things I've shown are actually sort of related to HTML5, like the CSS is a different specification, but most people, treat together CSS3 with HTML5. So this is no thing I show was CSS3. And then the SVG, the cloud in SVG, being able to use it directly in the HTML page is also a HTML5 feature. And then through the GObject DOM bindings, I was able to use, if you remember, the audio tag to play the sound in the DEFCON thing. That's also HTML5. And in general, we support any HTML5 feature WebKit has. We support it through the GObject DOM bindings. So yeah.
Also, I have something that I think many people here are interested in. Is it only compiled on i3, A6, or can it be compiled on ARM or other architecture?
Yeah, I mean, it's C++ and C, so in theory it should be fairly portable. I know there's people using it in ARM, so at least it works on Intel and ARM. I'm not sure about any other platforms. Maybe Holger knows, but
well, it should work on ARM, MIPS, SH3, Spark is mostly working. MIPS Limited contributed a JavaScript just-in-time compiler for their platform, so I think we're pretty good in the mobile space.
I think many people are very shocked at this wonderful, very cool idea, and it's very cool code you are presenting. And if there's no other question, we thank them for the wonderful speech. Okay. And we took a little rest. We take about 4:25, and then we'll start about 10 minutes, and we will start the next speech.